Kiran ma'am, let's start.
Good afternoon, everyone. Ma'am, screen is visible?
Yes, it's visible, ma'am.
So, good afternoon, everyone. I, Professor Kiran Ghate, welcome you all to the day 3 of FDP on cybersecurity and ethical hacking, concept tools and investigate techniques, organized by Department of Electronics and Telecommunication of Shalaka Foundation's Keystone School of Engineering, Pune. It is my privilege and honor to introduce our esteemed resource person for today's session, Dr. Leena Satpute ma'am, Executive Managing Director of Transcendental Technologies. Dr. Satpute is a distinguished professional with 20 years of experience in the localization industry, having made significant contribution in the field of translation, review, project management, client communication, data science, and independent research. She is an active member of prestigious organizations such as Indian Translators Association and Vicharak Manch. Her expertise span in team management, project management, query handling, and the effective use of CAT tools and emerging technologies. With proficiency in multiple languages, including Spanish, English, Japanese, Hindi, and Marathi, she has successfully breached linguistic and technological boundaries throughout her career. Dr. Satpute ma'am, remarkable achievement have earned her numerous national and international recognitions. She is a recipient of the Educational Excellence Award, National Education Brilliance Award, Best Teaching Award, Research Excellence Award, the Real Superwoman Award, and
I think there was some internet issue. We'll just wait for 2 minutes.
Yeah.
Sorry, there was a network issue. Dr. Dr. Satpute's remarkable achievement have earned her numerous national and international recognition. She is a recipient of the Educational Excellence Award, a National Education Brilliance Award, Best Teaching Award, Academic Excellence Award. Her contribution have also been recognized through prestigious honors such as Global Digital Leader Award. Am I audible?
Yes, ma'am, you're audible,
Yes,
but
ma'am.
breaking in between. It's fine, ma'am, you continue. Kiran ma'am, you can continue.
Ma'am, am I audible?
Yes,
Yeah,
yes.
you're
It's fine. Okay. On behalf of, sorry for the disturbance,
No, no.
on behalf of the organizing committee and all participants, आवाज नहीं जाते का माझी?
Ma'am, you're audible. No problem.
Okay. Okay. Yeah. Dr. Satkute ma'am will share her valuable insights on encryption and cryptography.
We welcome you, ma'am. Sorry for the internet issue which we are having. So, welcome you, and you can start the session.
Thank you so much. First of all, I would like to welcome all the participants to this critical topic. Actually, it's not an easy topic, but I welcome all to this interesting world of cryptography and encryption. And I also thank the Keystone College entire committee and ma'am for organizing such a wonderful event and allowing us to interact with all the participants. It is great opportunity for us as well. Thank you. Thanks a lot. Uh, so uh, Before we start, I would like to share my presentations with you. So I'll just share my screen and you guys can confirm if it is visible.
Visible, ma'am. Mm, you are mute. Can you just unmute, ma'am?
Is it okay now? I hope so.
Yes, ma'am. Yeah.
Okay, thanks a lot. I'm just turning off my video so that it should not be having any in connectivity in between. So I hope that is okay. Uh, so yeah. So as we are talking about encryption and cryptography, so I would like to take this opportunity to take everybody into the modern cryptography. So we are going from digital trust to post-quantum security, right? Uh, Very soon we will be entering into the
काहीतरी वायफायचा problem.
Soon we will be entering into the quantum era. There will be quantum computers pretty early, I think. Now there's a wait that will be over. So we are starting with the digital trust, and we have to carry on this part till the post quantum security when we are considering encryption and cryptography. So to start with, I would like to have a kind of interaction with all the participants, those who are available, that in this era at present, or the current cryptographic ecosystems that we are seeing today. So, what we are seeing today is that um, the need, why we need the cryptography and why we need the encryption, right? So I think all of us know that in this digital world, the way we are using the digital presence and we are handling everything digitally, right from the banking apps to the payment apps, right? We are having everything on online, like we are even having our data services on cloud. Now we are having the cloud based areas where you can put your services, where you can borrow the space to put your technologies, right? And also in some part of government websites, even nowadays few of the government sites are becoming digital. They are also providing some digital services likes of Aadhaar, likes of PAN card, kind of a things, where you don't have to actually physically visit any of the office. Everything is coming digital platform, right? So, and also we are nowadays communicating a lot via internet. Even the calls we are doing like online, like even we are using sometimes Wi-Fi calls like WhatsApp or any other chat, right? And of course, slowly we are moving forward to the smart cities, including the smart homes, where all the IoT devices will be implanted, webcams will be there, AI technologies will be integrated in all of such, new upcoming technologies. So the presence of this digitalization or overall online platforms, this has created, the need of cryptography or a need of encryption. Because, see, based on the statistics, like billions of encrypted transactions are happening daily, right? And most of the internet traffic is protected through TLS. Now, you guys must be having basic terminology understanding like TLS, which is the basic need through which we are communicating on the internet or the network, right? So, using all these platforms are also creating grievance, like they are also increasing the threats or the cyber attack possibilities on such platforms where we need the stronger security, and we want our systems to be secure properly. For that, the technologies that we are taking help of are the encryption and cryptography. So cryptography is no longer an option, right? It is basically the fundamental or a foundation of the digital trust of the network, right? This is what we can say. So everyone who is participating, I think you guys are aware of what all the basic cryptographic ecosystems we are using, right? You must be aware of symmetric cryptography, asymmetric cryptography, hash functions, and the very recent one is the public key infrastructure, right? So the major component, if you can talk about when we consider the modern cryptographic ecosystem, so these are the four major pillars on which the entire system is based, right? So in the symmetric cryptography, why we are using? Because it is fast comparative to all, and moreover, we are using the same key for encryption and decryption. When we talk about asymmetric cryptography, we know that there are two different keys like public key and private key. Okay. And we are also ensuring that the key exchange and authentication has been processed carefully to ensure that the proper channels are communicating with each other, and moreover, the message or the communication which the nodes are connecting with are secure. We are also using hash functions, which is ensuring the integrity of the data, right? If any message is passed or any file is passed, right? So, what we are ensuring, that we are ensuring the integrity of the data. Data integrity stays intact, right? So hash function gives us all the integrity aspects related to the data or a network. It's a verification, right? When we talk about public key infrastructure, we know that nowadays we have this trust management where we always have the digital signature, we have digital certificates, right? Each and every site nowadays, which we are putting on HTTPS, so more secure platform which we are using. So it is running based on the trust, right? So how that trust is managed, it is through the digital certificates that has been allocated. And how we are verifying the authenticity of that particular digital certificate is using the hash function. We are comparing the hash values, right? So this is how we are using the ecosystems in the current modern cryptography. And also when we are talking about the encryption systems, existing encryption systems, so if we talk about the symmetric encryption system altogether, then we know that the dominant standard right now we are using is advanced encryption standard, which is AES. So AES 256 is the utmost secure means of encryption that we are saying which exists today. So whatever digital certificates or signatures, if you can check the encryption or hash value, you can easily see that that is AES 256 protected, or it is with the formula or algorithm of AES 256. So when we talk about symmetric encryption, so what are the areas or where the actual application happens of this encryption system? So it is used basically for the disk encryption, the cloud storage securities, when we are using the VPNs to connect different PCs or altogether machines with each other. When we are talking about the Wi-Fi security, we want to ensure that it is secure, channels are secure. Then for that, we always need the symmetric encryption. Also, nowadays, we have the challenge of protecting the database, right? So not just the data, but the database also, which are there in the network, how we are going to secure them. For that, the solution is AES, or the solution is symmetric encryption algorithms, which will be applied to ensure that the database are protected. So when we are using such systems like symmetric encryption, so what all advantages we have is that we get the great speed. They are very fast to process. They are efficient even for the large volume of the data. Okay. And what we can see is that even the AES is globally adopted and widely used. Okay. So it is basically what we can say is that it is the industry standard, right? Which is AES 256. The very latest standard that we are implementing or using for encryption in terms of symmetric encryption is nothing but the AES 256. We are also using public key cryptographies, right? So core idea of the public key cryptography is based on two keys. So the fundamental is that it will be having two different keys, which is ultimately an asymmetric cryptography. Okay. So which algorithms are widely used at present are the RSA and ECC. So elliptic curve cryptography, in most of the cases, we can see that ECC is implemented for the public key system or even for the PKIs, right? So what are the actual application areas or the usage for this ECC are the digital signatures. Okay. So whenever we are talking about authenticating any of the email address or authenticating any of the website where we are saying that we are using the digital signature of that particular email address or that particular user, then that digital signature specifically is using the concept of ECC, where we will be using both public key and private key, which is generated and we will use the secret key or a private key to add into the digital signature so that it provides the authentication of that particular ID. Okay. The same concept of public key cryptography is also used for secure email communications, right? When emails are passed from sender to receiver, then the entire system or on the network is based on the cryptography or a encryption system of public key cryptography. Okay. Then also the same way earlier we used to have HTTP, right? To open any website, and if you read the website address, it used to start with HTTP. But now we are using the secure version of HTTP, which is HTTPS, right? So even for the HTTPS, nowadays we are ensuring that digital certificate is attached, a hash value is attached, a signature is attached to ensure that the connected sites or connected links are secure and can be opened securely for further communication. Then we are also seeing that this kind of ECC or RSA algorithms are used for authentication systems, right? So wherever the systems are particularly set to authenticate any of the activity or even passing of say transaction or passing of say uh, or authenticating the passwords or entities. So for such, we are definitely using the algorithms which are RSA or ECC. So what are the current trend? So current trend, if we talk about, then most widely we are replacing RSA by ECC. Now, if we talk about the public key cryptography, the more secure algorithm is nothing but ECC. So why it has replaced RSA? Because ECC itself is having the smaller key size, right? And its performance is better than RSA. And if we talk about the security again, since it is based on elliptic curve formula, its security becomes more stronger than RSA. So these are the two algorithms that we are currently seeing. But slowly, as we are moving into the modern cryptographic world or more towards what we can say more difficulties and challenges that we will see in modern cryptography. So, as a solution, we are looking at ECC to bring more security and stronger security. So we are using ECC. Okay. So how these keys are getting generated? So I've created one very small lab for you using Kali Linux. Actually, how these keys are getting generated and using these formulas. So allow me to share another screen with you. I hope my screen is visible.
Yes, ma'am, it is.
Okay. So what we are doing is right now I've opened a terminal in a Kali Linux. Okay. And there, let's try to see if we can create keys that we are talking about. So what I'm doing is that right now in Kali Linux, I'm creating one dictionary, okay, for the demo purpose. So I'm giving the command mkdir crypto demo. Okay.
Ma'am, can you just increase the font size a
Yeah,
bit?
sure. I'll do that.
Yeah. Thank you.
Yeah. So
Yeah. Thank you.
mkdir make directory crypto demo. Okay. So I'm making a directory, and now I'm going into that directory to the work, right? So I am into the directory which I have created just now. Okay. So now to check my current location, I'm giving the command pwd, okay, which is giving me the idea exactly where my folder has been created. Okay. Now to generate the RSA private key, I'm using following command. Okay, where I'm using the command open SSL generate RSA, okay, RSA private key, okay, and we are giving the bit size of 2048. Okay, so I am generating a private key. Now I'm checking that particular file which has been created, so with the ls command. Okay, so RSA private key has been generated, right? Now to view that private key, I'm giving the following command. Okay, where I want to see and check that private key which has been generated. So as you can see, if I type this command, I can see what all things have been generated for the private key, right? So this is how the private key is getting generated using Kali Linux. Okay. So as you can see, there are 2048 bit key has been generated, right? And you can see the exponents, coefficient, and the private exponents and the key which is getting generated using this command. Okay, so this is how we can generate the private key. Now, similar ways, we want to generate public key using the same environment. So I'm giving this command. Just let me type it out. Think. So open RSA slash remove the unnecessary spaces in between. So this is the command. Again, I am creating the public key. Okay. Okay. So now to check that particular public key, I can give the cat command. Okay. So this is how the public key is getting generated. So entire this thing will be a public key. Okay. So this is how the keys are getting generated. Now to check the key size, you can give the following command to confirm what is the key size. Okay. Okay. So now it is showing you the key size is 2048 bit. Okay. So this is how we can generate the keys. Again, the similar way as we have generated the keys for RSA, the similar environment we can use to create the key for ECC. Okay. So, so I'm giving the command OpenSSL ECP ARAM and I'm seeing the list. Okay. Now in this list, so all these are the listed, what we can say, the ECC formats which we can use. See, this is the 112 bit or this is 160 bit, right? This is 192 bit. Okay. This is 256 bit. So all these are the different formats for the ECC which can be used, right? So now here, let's try to create one key. Which will be of 256 prime. And bit key. Okay. Now I will list it out to check if I'm getting it. Okay, so here you can see one ECC private key and the RSA private key and public key which we have generated right now, right? So to display this particular key also is possible using this Kali Linux. So we can use following commands. We are opening the ECC environment again, and we will be asking them to print this key which we have generated and what is the text inside that key. Okay, so you can see EC key, as you can see, this is the private and this is the public. And you can see the format which we have selected is prime 256. So it has been displayed here, right? So these are few of the technologies as we can see, say that we are using, okay, by using the Kali Linux environment, and we can generate such private key and public keys. So in this way, it is getting generated and it is getting added to give the more secure layers for the uh, generation of the keys infrastructure specifically, because as you know that everything will be based on key, right? So if you have the strongest private key, then you are having the strongest encryption, and you will be more secure in terms of, you know, getting exposed, or if somebody's fetch information. Is my I hope I'm audible, right?
Yes, ma'am. You're
Okay.
audible.
Okay. So this is how we are saying then that when we are using the public key infrastructure, the overall base of that particular infrastructure or the modern encryption is completely relying on the key structure. If you have the strongest keys, secret or private, then it is giving you that much, security, and we can say that our algorithms are strong enough to keep us away from the threat or attacks which will be tried, right? So if you have more secure keys, then the overall security or the encryption or the cryptography of that particular thing will be strong enough if the keys are strong. And how the keys will become strong? By using the strongest algorithms to generate these kind of the keys, right? So the algorithms which we are using recently are based on ECC, so that it gives us the best possible outcome, and it will try to secure the keys, or generating more stronger keys, and that will ultimately help to secure our data, database entries, the communication, network communication that we are having today, or the digital platforms. To ensure their security, we are generating these kind of public key infrastructures. So I hope with this bit of explanation, you were able to understand how the keys are getting generated, right? Okay, so to move ahead, let me share my PPT again. So we can generate public key, private keys, right? Uh, we can even check the file size in which these keys are generated, right? So these are the few commands where you can actually check the file size of the key, where the key has been stored, right? Also, we can use this particular Kali Linux environment uh, to create the digital signature for RSA or even for ECC. And further on, we can also see and check if it is, we can verify the signature and we can ensure that the signature is matching and the hash value is matching and the signature is authenticated. So let me share the screen once again. Clear this. Okay, so let's try to create one small testing for verifying the certificate. Okay, so I'm creating one message text where I'm having this message, hello faculty workshop. And then let's try to see if this file is created. So I'm using cat command. Okay, I can see the file is created. Now let me sign this message with the digital signature. Okay, so I'm opening that port to sign this digitally. To sign it digitally, I'm using SHA-256 algorithm. I'm using my RSA private key, which I have generated to sign this particular document. I'm applying this RSA signature to my message text. Okay, so I've applied this signature. Now I want to verify this signature which has been applied. So I will again open SSL. I will apply SHA-256 algorithm, which I was using. Then I will verify the RSA public key. And then I'm going to check the signature for message txt. Okay, so what message I'm getting is that verified okay, right? So this is how actually these algorithms will help, you know, uh, the network or the platform to check the signatures. If these signatures are correct, they are not non-corrupt. If they are getting corrupt, then this particular signature will not be verified and it will be message failure, right? Now, when we talk about this kind of SHA 256 or any algorithm, we we all know that it is using the hash values, right? So if I may join all the participants, that what is the peculiarity or what we can say the advantage or a very key advantage of hash function? Can anyone participate? Will anyone like to reply? I hope it is okay to ask questions, right? Ma'am? So if you can, participants, if you can unlock yourself, unmute yourself, and would like to participate in this. What is the feature of hash function?
It creates a fixed length of output.
Yes. And we all know that hash value changes if somebody tries to make any changes in it, or if somebody tries to what we can say, modify it, or somebody is trying to get into it. So what happens is that any minor change in that particular file or any message is going to create altogether a different hash value. Even if it is a single change of a space in the end, even that is going to create completely different hash value than the previous one which was there. So if I have created message.txt with certain message earlier, it has a very specific hash value when it got generated, right? If I try to change anything into that, it is going to create complete different hash value altogether, right? So this is why we are using this particularly to check the integrity of the data. That data has not been tampered, and the message is exactly matching with the original message or not, right? So let's try to do one thing, that let's see if we can modify something in this particular file and see if the verification is going to run. So I'm doing a change, and again I'm trying to verify it. Okay. If this is going to give me the result, if there are any changes made in the existing message. See, if I'm doing any kind of a change in here, if I'm adding double space than the original sentence which I had had. Earlier we had hello faculty workshop. Now which I have modified and tried to change as hello faculty workshop modified. Then you can easily see that that signature is not matching with the earlier message.txt file. So the verification is failed, and it is giving me that the signature is not matching. It is saying the bad signature. Okay, so this is how the ideology between the use of private key and public key is what we all see, right? So you know, when we are having public key and private keys, right? So how they work, right? So public key and private key, if you know the how email works, then you must be aware that the public keys always float into the network, and which is easily available for others to interact with you. So every email address or every account is having two keys, like public key and private key. So the private key is a secret one, which stays with the accounts, which is not known, right? Which only the account holders will have in their pocket. But public key is floating in the network, which is easily available. So if anyone want to communicate to any email address, what they are doing, they are using that particular email address public key to send the message. So public key is always used to encrypt the data, whereas private key is always used to decrypt the data. Okay, so this is how we know that all these public key infrastructure, they've been used, and these technologies have been used. Okay, so this is how, if you try to tamper anything, the verification will be failure. Okay, so similar ways you can check for the ECC digital signature as well, right? So I would like participant to interact in this communication. We have seen the performance of ECC. So can anybody just give me a brief why ECC would be preferred in mobile and IoT devices? What could be the reason that we are preferring ECC in the mobile devices or IoT systems? Any guesses? Would anyone like to? Yes, I think Anida ma'am has said it correctly. Key length is small. Definitely, the length of the key is small. And anyone else with any other thoughts?
Ma'am, you're on mute.
Hello, I hope I'm audible.
Yes, ma'am. Now you're audible.
Yeah. So exactly, the key length is small, processing is fast. Also, since the key length is small, the memory requirements are also low, right? That is why the processing also becomes faster, and it also consumes a very low power, right? So that is why we are using or preferring ECC more in the mobile and IoT systems. When we talk about hash function, obviously the prime requirement why we are using hash function is data integrity, right? We want to ensure that the data has not been tampered. So what all popular hash algorithms we are using is SHA-256, right? Which is the very latest SHA series, secure hash algorithm. And the upcoming series will be SHA-3, right? Which will be needed definitely once we are having the quantum computers. So what all uses we can see for the hash algorithm is that for the password protections, or it is commonly used in blockchain technologies. The digital signatures, they are encrypted with the hash, or they are rather converted to the hash values. Then the software verifications, where we have the hash keys or hash IDs, right? So, password protection, as we all know that with the recent all
आम्हाला का बर्थडेच
thesis
होणार आहे
or
समर्थ
studies which we have,
आम्हाला का बर्थडेच होणार
I think somebody is on unmute. Mic is on. Okay. So when we are talking about the password protection, uh, so why we need to convert that to hash, the password protection? Because there were incidences in very early stages of encryption and cryptography. Earlier, the passwords were stored by doing the encryption. So passwords were encrypted, and encrypted passwords were stored on the servers. So what happened that the brute force attack, or the attack commonly was done to get the password information for any accounts, right? So due to that, the passwords with very weak, what we can say, the combinations or the weak combinations of alphabets and numbers, like somebody's name, birth date, these kind of weak passwords were like very prone to the attack, right? The dictionary attack or the brute force attack, or even if somebody tried to keep it for the 16 digit password, 8 digit password, still just encrypting them was not enough. So there were earlier, you might have heard like cases where Google passwords were breakthrough. Lot of database got like exposed or got hacked, where the passwords were just encrypted. So whatever the encryption formula applied, if the hacker gets insight what could be the algorithm, they can easily decrypt or the encryption done files, and they can get the entire password database, right? So for that reason, the new system what we developed is that whenever you create a password, that password gets converted to hash value. So we are running the hash algorithms in the background and completely converting that password into the hash entity, right? So one of the best example you can see that online banking systems that we are using, right? So if you enter a three times a wrong password, ultimately your online account is getting locked, right? If your account gets locked and if you try to reach to bank authorities, then bank authorities are not giving you back the password. What they are asking you, they are asking you to recreate the password, right? So your account will recreate a password and that hash value will be stored on their server. So bank authorities will not be having the actual password which you have entered. They will be having the converted hash value for that particular password. That is why retrieving that password is not available, right? So if you lose your password, then there is only way you can get it back is recreating it. Banks are not going to share you the passwords as is, because they are getting encrypted or they are getting converted to hash. Similar happens in digital signature. Now we know blockchain technology is widely used for financial institutions or bigger, what we can say, market industry or retail industry, all are based on blockchain. So even blockchain is registering all the histories with the hash value. So hash algorithm is commonly used in there. So its characteristics as such are, it is the one-way function. You cannot revert back the hash values. Again, the fixed length output we are getting, and it is collision resistant. So whatever entries we are adding, or whatever input is there which is getting converted to hash, every time whatever you are entering, the hash value will be different. It will not be the same. So it is collision resistant, right? So as I have shown you, any tiny change in the input will also create completely different hash output. As we have seen just now, the sign is not going to match if somebody is trying to change the file, change the message. If somebody is trying to tamper anything, the message that you have sent via network, then any change in that particular message is going to create a complete new hash value, and hence the uh, authorization will fail. It will not verify that it is the correct certificate, or digital signature will not match, and then it will help for further exposure or attack kind of a thing, that the mail will not be dropped into the box. It will not be available if that verified signature is not matching, right? So this is how we are using the popular hash algorithms. As we have seen, the public key infrastructure is also there. Okay, so what are the basic components, or the foundation is the trust. So how we are going to get the trust, gaining the trust, is that certificate authorities, digital certificates, registration authorities, and certificate repositories. So these are all the foundation of gaining the trust on the digital platform. Applications as such we have talked about are the HTTPS websites, digital signature as we can check for each website. Then also for the government e-services nowadays, whatever the applications are there, for that also we are using PKI. Corporate networks, they are also using the PKI infrastructure altogether, right? So how does a browser trust a website? Anyone aware of? How does browser is going to trust a website? How we are going to trust any of the website? What is the key? Okay. So key here is certificate validation, right? What we are doing is that we are seeing the certificate validation. So certificate validation is the only method that we are going to see if the website is trusted or not. Okay, this you must have seen or practicing transport layer security. Why we are using TLS? Because it protects web browsing, banking transaction, any kind of cloud application, or different sorts of APIs if you are uh, accessing them. So to protect or do the secure communication, we are using the TLS. So common protocols are HTTPS, SSH, VPN protocols, or secure email. If we talk about day-to-day life examples, then online shopping applications or UPI payments that we are doing, internet banking that we are doing, and video conferencing. All these are secured with TLS security, right? So We are using TLS for it. Now, when we talk about all the technologies, all the modern aspects, then what are the technical challenges that we see today in terms of cryptographic ecosystem? Okay, the major challenge is the key management. As we are saying that we want a very secure key infrastructure where the keys are secured, right? Specifically, if I'm talking about the secret key and the private key. So my key management becomes very, very crucial, right? Not just that, but it should be scalable, right? We are using day in and out different sorts of platform, digital platform, different applications, different kind of servers. Then we also need some algorithms which are compatible, which are scalable with all the platforms, right? And also we have the performance overhead, right? As we try to increase the size of the key to make it more stringent, it is ultimately going to impact the performance, right? So these are the technical challenges that we are facing when we are talking about the current cryptographic ecosystem. If we talk about the security point of view, what are the security challenges? The very first challenge that we are going is the quantum threats. All the existing algorithms, ECC, SHA-256, SHA-3, all are working well for current all the threads. It's fine. But when we are moving towards quantum computers, then quantum computers are way faster than the existing algorithms that are working, even way faster than SHA-256 algorithm. So these kind of quantum computers can decrypt, or they can just break any kind of difficult algorithms in fraction of seconds. Okay. So again, if there is a quantum computer, it will be a quantum threat for the existing algorithms that we are using for cryptography. Another security challenge is that poor implementation practices. This is very commonly seen, right? So we are saying that the password should be strong enough. We are putting some restrictions, how the password should be created, how should be the password, etc. But despite of everything, we are seeing that the actual implementation of these kind of passwords or the security practices are poor. Sometimes they are not followed correctly. So again, that will be a challenge for the security. We are also having insider threats, like insider attacks. Many companies nowadays have data breaches, kind of a thing. So somebody from internally from the team who knows the security norms can break and pass on the information. So this is again another level of security challenge. And of course, in few cases, the human errors, right? Human errors as in we are taking practices, we are taking sessions on the cyber securities, that do not click on any of the unknown links, do not open any images, do not open the messages from unverified sources. But somehow, if people are falling into the trap, then that is a human error. There is a gap. So this is the very basic and very major concern that we are seeing today. Why the cyber threats are increasing, why cyber attacks are increasing. because of these kind of security challenges. When we talk about the educational industry, then we have the biggest challenge of bridging the gap between the theory and actual industry deployment, right? Where we have sometimes challenges upon using the open source tools. We cannot borrow the tools or the very high end license copies, right? So there we have a gap that we can have everything in a theory, but actual practical implementation could be lacking, right? So this is one of the challenge when we talk about from the educational point of view. Now, when we are talking or going ahead into the era, we are going more into the cloud. We are going more into the AI, artificial intelligence. Many things are already there coming on blockchain, and there are already few devices implemented from the IoT, right? So how we are going to manage the cryptography? So why all these topics are important? Because of the digital revolution that we are seeing today. Now we are seeing earlier days companies used to have their own servers, their own server rooms, right? But nowadays, what is happening is that companies are cut shorting on their cost, and what they are doing is that they are buying some space in already somebody existing cloud, AWS cloud, Amazon, Azure, right? So these cloud space are already available. So what we are relying on, we are taking the space and we are putting our own technologies, our own services into the cloud. We are seeing more of artificial intelligence and machine learning is improving, right? Nowadays machines are also talking. There are huge number of research going in robotic industries. Nowadays we are seeing few operations in the hospitals are also taken care by robots, right? In absence of doctors, minor surgeries are taking care by robotics. So we have the robotic surgery. So as we are seeing that these artificial intelligence and machine learning fields are also increasing, it is also again giving you the increased level of security requirement. Blockchain systems should be secured properly. Otherwise, it is a chaos. Internet of Things, IoT, all the devices should be secured. Otherwise, there is a threat of hacking those devices. Okay. So, core security services that we all know what the basic of the cyber security is: confidentiality, integrity, authentication, non-repudiation, and privacy. These are the pillars when we talk about any kind of cyber security. We want only authorized user to access the data. We don't want any unauthorized persons to update the data or change the data. We want verified identity to use the devices. And we don't want to lose a candidate or a user, or we don't want any escape window where user is going to deny that he has not worked or he has not accessed any particular thing or the action which has been done which is not ethical. And we also want to ensure that all the sensitive information is protected properly. So these are the core concept of entire cybersecurity services that we all know, right? So when we talk about the cloud security technology, right? So when we see the modern cloud environments, they are very complex, right? And since they are all connected via network, their security becomes very crucial, and they are open to cyber threats more of. Okay, so key technologies in the cloud security innovation that we are talking about are zero trust security, confidential computing, AI driven security, and homomorphic encryption. So these are the new eras which we have to consider when we are talking about the cloud security. Okay. So these technologies will give you more enhanced functionalities for data confidentiality, earlier threat detection and response, access controls, privacy preserving, data processing, right? And organizations are adopting these kind of technologies will also face few challenges. Okay, the basic challenge is when we talk about the entire cloud security system is about the performance. The performance of that cloud platform should not fall off. So it is a performance overhead. They are not very easy to implement. They are complex structures. When we are talk about homomorphic encryption or zero trust security, they are not easy. They are complex. They need high deployment and operational cost is involved. So everybody cannot afford it, right? At this point of time. It has the regulatory and compliance requirements as well. You must be aware of ICMS or other security audits like 27001 and the others. Okay, so companies, those who will implement these kind of technologies for the security, they have to go through some regulations and compliance. Then we have the shortage of skilled cyber security professional. Not everybody is aware of these kind of technologies or the innovations that is going around, right? So the future of
Hello.
cloud security will lie in combination of advanced technologies. So we want the skill expertise, right? We want somebody to continuously monitor the cloud space, and we need the strong governance to ensure that the environment is secure. Right? So emerging cloud security technologies, if we talk about, so few I have listed here. So we have CSPM, we have CNAPP, we have zero trust security architecture, we have secure access service edge, we have confidential computing, homomorphic encryption, AI driven security, XDR, container security, blockchain security. All these aspects become very, very important when we are talking about the cloud security technology. Okay. So every security is having its own prime benefits. So depending on the requirement, either of the technologies or the combination of the technologies for the security purpose can be taken care of. Okay. Now, when we talk about artificial intelligence and machine learning, what is the most important thing is data security, right? Everyone agree with me? right? So when we talk about AI or ML, so it has its own cryptographic importance. So we want data privacy in terms of when we are creating the models, they process sometimes very sensitive information such as personal data, sometimes financial records, sometimes medical information, sometimes government data. So what we want is that that data is protected. So how cryptography is going to help us? It will encrypt the data when it is at rest and when it is in transit, both the phases, right? If I'm having data sitting on the server, which is data at rest, I don't want that data is easily accessible for the hackers. When data is at rest, it also needs some kind of security. And when I'm passing a data confidentially in transit, also it needs a security. We want to prevent unauthorized accesses, limited access control should be implemented. We want to support the privacy preserving AI applications. We want to preserve the privacy of any personal or confidential information in that AI application. Okay. One of the good example what we can thought of is the healthcare. Many hospitals nowadays are using AI models, okay, to analyze patient records, right? But when we are talking about the patient's record, it is very personal information, okay? So it should be encrypted. It should not be exposed to any unauthorized person. So when we talk about the patient records, you can see only those specific doctors will have the access of that particular patient's history. Not all doctors, not all nurses, or anybody from that healthcare institution is not going to have the access to that particular database. So it is restricted where we are implementing the roles, right? We are dividing it to some categories, right? So this is how we are going to preserve the privacy of the data. We want to secure data sharing, right? So organization frequently collaborate and shares the data information
हे नको येऊ. खाली
for
जाणार नाही ना
AI
तो
training.
पाय
As we know that we are training the models many a times, right?
पुढे म्हणून
So to
येतं ना
train the models, we need to pass on or share the information or share the data. Okay. So for that also we are using the cryptography. So what it does, it will protect the data during transfer. It will enable multi-party collaboration. Secure channels will be established, and the different parties will communicate or transfer the data in those secure channels. Okay. This is how it will reduce the risk of data leakage. Okay. Example, if we talk about, then multiple hospitals jointly uh, train a disease prediction model or without exposing the patient data, right? As we know that medical industry is also growing, they are also doing some research. They are also thinking of some, they are collaborating to define any drugs, or doing some research on a drugs. So all such predictions or data, with that they are training the models, AI models, right? So for that also we are using the cryptography. Then when we talk about the machine learning, it should be confidential. Okay. So what cryptographic techniques or algorithms are doing is that they are operating on encrypted data, right? So data is never available in the plain text format. it is getting encrypted, and that encrypted data is going into the AI models, and that AI models are getting learned with the algorithms. So for that, which kind of technologies we are using are homomorphic encryption or multi-party communication or confidential computing. So these kind of security techniques or algorithms that we are using. So what are the benefits? So data remains protected during the processing. It is encrypted, not plain text. So data remains protected during processing. Cloud providers cannot view the sensitive information. So whatever sensitive information is, it is in the encrypted format, and that encrypted data is getting processed. Privacy preserving AI. So what is that? It is a technique which will ensure that data is kept private while training that AI models. Okay, we want to secure or protect the sensitive data. Okay, these kind of AI system are going to build the trust. Okay, key approaches what we are using is data anonymization and secure multi-party computation. So these are the approaches that we are using in this particular technology. Key technologies: homomorphic encryption, multi-party computation, federated learning. Federated learning is nothing but the models are trained locally. This is how we are going to preserve the privacy, right? So models are trained locally. Only required data passing will be done in the encrypted format for the learning purpose. Differential privacy. So differential privacy, what we are doing is that we are adding noise to protect the individual record. So whatever the original record is, we are adding some buffers, we are adding some bytes, additional bytes to create the noise so that the original record will remain protected. When we talk about secure federated learning, then it is one of the decentralized approach to train the models. Okay, again here we are collaboratively sharing the raw data. So 4 or 5 different systems will collaborate and share the raw data. Okay, so process our local models are trained on user devices. Only model updates are shared with central server. So there will be one centralized machine which will have the model updates. So only the updates are shared and not the actual training which have been done on the local models. Examples: 3 hospital want to build a disease prediction model. Then what is going to happen? Hospital A keeps a patient data. B and C will also keep patient data locally at their machine. A, B, C will be having the patient data. Okay. Each hospital will train their own data. Okay. And only those model updates will be sent via central server. So server will combine the updates which it has received from ABC, and then it will distribute the improved model. Okay. So in this way, what we are doing is that we are preserving the privacy by collaborating AI training. So data has not passed. Data is on the local machine. Only trained model updates are passed. So we have reduced data transfer and also the requirement for the storage of the data. So when we are using these kind of learning or technologies, what are the challenges? So we want to ensure the accuracy of the model. It becomes very, very crucial. And how to handle the heterogeneous data. For that, we need to develop algorithms and models. So these are the two challenges. When we say homomorphic encryption, so what is that? So that allows, this is a particular format of the encryption which allows the computation on the ciphertext to produce encrypted result. And when we decrypt the result, the outcome will be matched on the plain text. Okay? So key features are fully homomorphic encryption supports both addition and multiplication. So when we talk about the homomorphic encryption, it is completely based on addition and multiplication. So when we say addition and multiplication, it is binary addition, binary XOR, binary things, all the applications that we use. And it will use the modulus operation. So modulus addition and modulus multiplication. Okay. So partially homomorphic encryption supports specific operations. These are the key features of homomorphic encryption. When we talk about the application, as discussed earlier, most of the cloud environments nowadays are secured using this type of encryption method, where it enables the privacy and preserve the machine learning. Right? What challenges we have are computational overhead, complexity of implementation. It is not easy. Although the algorithms that we are using are simple, modulus, addition, multiplication, XORs, but actual implementation on the cloud system makes it difficult, makes it more complex, right? So as an example, if we consider a scenario that a company stores employee salary data in cloud, right? So what is the approach traditional? Data must be decrypted before processing, right? If we think about the traditional approach, if anything is encrypted and shared to the server or a machine, the first thing in traditional way, what we will do, we will decrypt it and then process, right? So if we, once we decrypt, it is exposing for an attack. Attackers can wait there to check as soon as it is getting decrypted if they can attack it. Okay. But when we talk about homomorphic, then what happens? That encrypted data remains as is. But on that encrypted data, cloud will do the calculation of total payroll, average salary, bonus distribution, what all things needed, and the results that we are getting will also be encrypted and will be returned in the encrypted format to the specific machine. Understand? So during transit and during operation, the data is not getting exposed for the attackers. it remains intact. So these are the new technologies which are working directly on encrypted data instead of making them or converting them back to plain text. Differential privacy. Again, one statistical technique, okay, to add the noise. Okay. So what mechanism we are using? We are introducing the randomness to the database or the data sets. Okay. In this way, what we are doing is that we are ensuring the results are statistically similar regardless of any other information, if it is included, excluded, anything. Results are statistically similar. Okay, this is the mechanism that we are considering. So real-time applications, when applications release of aggregated statistics, we all know the census data that we see online, right? Training machine learning models without revealing personal data. For this, we can use the differential privacy. So what challenges we have when we are talking about this particular security, like differential privacy algorithms? So we have to balance privacy and data utility, both, right? So when we talk about adding the noise, then what level of noise should be added in the data? That should be appropriate, right? If you add unnecessary noise into the data, the statistical application is going to ignore that data if the added noise is too much. So here the challenge is balancing privacy and data utility. So one of the example is that a security company wants to share statistics about phishing victims. Okay. So victims in region A is 250. So when they want to publish a data, always there will be either a less amount.
की होती तो अलग बात है बाकी ऑटोनोमस में तो एडमिशन प्रोसीजर तो वो काउंसलिंग से ही होता 3 टाइम
Swapnil sir, please mute yourself.
फार्मेसी को पहले नेक करना पड़ेगा अब ये नेक में जाएंगे
Sorry, Lina ma'am. Please continue.
Yeah. So see, when we see the census data as well now, these are the kind of predictions, right? So aggregate statistics will never be the exact data or exact value they will mention. They will always add some noise. So it will be plus or minus. So either it will be slightly less or slightly high. So why we are doing it is that what is the benefit is that it is useful threat intelligence, okay, without exposing the specific victims. Any information which you are publishing, if that information you try to give it very precise, then it becomes very critical. Okay, it can be attack prone. So what we are doing is that we are using this differential privacy, we are applying algorithms and we are adding some noise to give the statistical data. Okay, there will be noise added and we are somewhat trying to reach or keep it somewhere close to the exact amount, somewhere similar, going close. Okay, So this is how this differential privacy will work. AI cryptography uses AI plus cryptography, what we can say, the major sectors currently which using AI and cryptography both are healthcare, banking, smart cities, and even the education industries. When we are talking about the healthcare, we know that nowadays we are having AI diagnostic models. Nowadays, you must have seen in the villages, they have some institutes or things where patient can tell what symptoms they are having, and after hearing them, the AI model can predict what could have been happening to the patient. So if you see that I'm having a cough, I'm having a headache, then it might suggest you that these are the symptoms of, say, suppose some allergy or allergic infection or something like that. And uh, if doctor is not present, the based on your uh, history or description, what you have mentioned, it can also suggest some basic medicine. Okay, so it's commonly now in use with the healthcare. Banking, we of course know fraud detection becomes very, very crucial, right? So maintaining customers' privacy. Nowadays, you must have seen that if you are using the credit card and if you have done transaction to certain level, then as soon as you try to go beyond a limit, say if I have done maximum transaction, highest transaction done last 5 months of 10,000, as soon as you try to spend 15,000, nowadays immediately you receive call from a bank to confirm that the transaction is being carried out by you. So these are the fraud detection techniques which banks are using. So there we are monitoring, the pattern of transactions through AI, and then we are using the cryptography as well, right? Again, the traffic analysis, traffic signals nowadays, we are using webcams, so traffic analysis, and we are revealing individual movement patterns through the traffic, what had happened, if incident happened, how, what had happened, kind of a things. Okay, so for these analysis also we are using AI and cryptography. Learning analytics nowadays, for the protecting students information, each student has some different data, different privacy, right? So all student data should be kept private. So these kind of learning analytics we are using AI. So these are few challenges: limited devices, massive scale, physical exposure, IoT, when we are talking about the IoT devices. So mainly smart homes, smart agriculture, industrial IoT, IoT security architecture, or will fall into it. So this will need the cryptographic support to secure the system and secure the machines. So here we need device authentication, secure communication, firmware integrity, and access control. Okay. So in this IoT, nowadays we have lightweight cryptography. So why lightweight cryptography we are using? Because this is the particular system which is designed to provide scrutiny, security with minimum resource consumption. Okay. So if we talk about the complexity, it is low, it reduces the memory usage, and it is very efficient in terms of energy. Okay, so lightweight cryptography, again based on symmetric key algorithm, asymmetric key algorithm, and hash function. Okay, so it is an efficient method of generating, distributing, and storing keys. Okay, which is needed for IoT devices. So symmetric, again, block cipher is used, 64-bit block size is used. Okay. Key size, when we talk about 128-bit size of key is used. Okay. And encryption also support 128-bit block size. Okay. And it is constrained devices which are designed, which will have the algorithms implemented as LEA. Advantages: it is fast. There is very minimum requirement of the hardware. For asymmetric key, again, public key infrastructure is used. Okay, focus is mainly on the compact representation of the keys. So key size is kept minimum. Okay, so due to minimum key size, again, the computational overhead will be minimized. Hash function, it uses SHA-256, which is the reduced version and most strongest version. Sponge construction is used, which is highly efficient. Okay. If we talk about the use cases, it is integrity checking, digital signature, message authentication in IoT, right? Challenges, of course, security versus performance trade-offs, balancing high security devices with the low resource use is a challenge. Standardization is needed. We need some standard norms accepted universally before we implement these kind of cryptographic algorithms. Backward compatibility could be a challenge. I mean, implementing this method or algorithm and making it compatible with any other system which are getting connected to IoT can be a challenge. So future trends in lightweight cryptography are, of course, AI and ML. Then post-quantum cryptography, where we can uh, prepare these kind of solution to minimize the quantum attacks. Uh, yeah, and of course, we need the continued research on this, developing different algorithms, improving existing ones, right? Again, blockchain, everybody knows, right? Financial crypto systems, cryptocurrencies majorly use the blockchain. Uh, Healthcare system use blockchain, education system use blockchain, secure e-governance, governments portals are using blockchains. Okay, and these blockchains are commonly secured with SHA-256, right? Where we are using it to verify the ownership and the transactions are digitally signed. Okay, we are using public and private keys to secure identity of that particular user or entity, right? So again, cryptography in blockchain becomes very, very crucial. Okay, this is one wallet creation lab. Since we are running out of time, I'll just skip this one. But yeah, so why we keep the private key secret is basically when we talk about wallets or any financial institutions or government systems, then private key is your secret key. Private key is always used to decrypt the things which have been passed, be it transaction, be it authenticating the digital certificate, be it authenticating the identity. For that, we need the private key. So private key needs to be kept secret, and that also need another level of security. So digital signature, again, as we have seen a bit earlier, we can create, whenever we create the digital signature, hash will be created, and that hash value will be mapped. If it is matching, the hash value matches, it will be considered as the verified digital signature. Okay. verification also done to authenticate whatever transactions are happening, if they are valid or not. Again, here we will compare the SHA-256 value of a private key, and then we will try to map it and confirm if both the values are correct. Then we will say that the verification has passed and that transaction can be processed. If somebody tries to tamper anything in between or modify the transaction, we always know that any modification to the existing message is going to create a new hash value, and ultimately it is going to fail the verification. Okay. So this is one of the case study which I have shared, that there was one case study with the RSA key vulnerability. Okay. So background is that RSA remains one of the most widely deployed public key crypto system. Okay. Its security majorly depends on large prime numbers, secure key generation, and proper randomness. Okay. Critical requirement is that strong random number generation. When we talk about the prime numbers, it should be very, very random. Okay. So what was the weakness is that researchers discovered that many internet devices generate very weak RSA key. The algorithms that they run to generate the keys, public key or private key, they are very weak. So poor random number generators are the reasons why it is prone for a vulnerability. So embedded system were used, routers, smart devices, IoT devices, or multiple devices that produced related or identical keys. It could happen that whatever keys are generated, there could be some possibility that two different devices or multiple devices are producing identical keys. Okay. So RSA relies on the difficulty of the factoring. So this is the mathematical formula n is equal to PQ, where P and Q are the very large prime numbers. So all game will fall on what is the selection of P and Q. They should be very random large prime numbers, right? So if attackers discover these prime numbers, if they can guess prime number, they can discover the private key. They can reconstruct the private key, and then encryption becomes inefficient. Okay. Suppose two device generate RSA key using insufficient randomness. So if randomness is weak, okay, then whatever the prime number is getting generated, okay, it uses greatest common divisor, GCD, and it will discover the shared factor. So once a factor is found, private key can be recovered and device security will collapse. So it is very, very basic algorithm which is used. That is why if the randomness is weak, it is going to produce the weak security. So large scale internet scans revealed that thousands of devices sharing factors. Repeated RSA keys are getting generated, and there is a predictable key generation which attackers can guess. Affected systems are network appliance, smart cards, embedded controls, consumer electronics. So RSA algorithm itself was not broken, but there were flaws in the implementation of RSA. Okay. So this, why did this happen? If we consider the root causes, it was devices lacked with the randomness, limited hardware resources were used, manufacturers generated keys incorrectly, and there were lack of security auditing. So weak keys remained unaudited and they remained in the production and reused. Okay, so this was the one case which I thought to share with you how these kind of algorithms work and their practical implementation, how it works. So I'm going quickly through one of the last slides, which is zero knowledge proof. So this is another technology that we want to use, or we are rather using it, a cryptographic method where one party is prover can convince another party as a verifier that the statement is true without revealing the actual information. Importance is that it is protecting the sensitive information, maintaining the integrity and verification process. Key principles: completeness, soundness, and zero knowledge. If the statement is true, the verifier learns nothing beyond the validity of the statement. Soundness, if the statement is false, no cheating, prover can convince the verifier that it is true. Okay. If the statement is true, an honest verifier will be convinced by the honest prover. Basic framework मध्ये we will need prover and verifier. The one who wants to prove the knowledge and another who wants to be convinced of the truth of the statements. So process is: prover prepares a statement to prove, prover provides evidences to the verifier without disclosing the secret, and verifier checks the evidences and confirms the truth of the statement. This is the basic framework. So authentication is proving knowledge of a password without revealing it. Enhancing privacy, it allows users to verify transaction without needing to disclose the identities or amounts. Okay. These kind of systems are used for voting system, online voting system, e-voting system, which are secure, ensuring the votes are counted correctly without revealing individual choices. Secure communication protocol, SSL TLS, improving the security of the protocols. So this was the one example, Alibaba cave. Imagine the scenario, a cave with two paths A and B. So the prover will want to prove to verify that they can navigate from A to B without revealing how actually they are traveling inside the cave from A to B. Right? So in a process, prover enters from cave A. The verifier waits outside and asks the prover to come out from either A or B. If the prover know the path, they can always come out from the requested exit, convincing the verifier without revealing the actual path. If verifier asks person, prover, to exit from the end B, and if the prover is going out from exit B, then verifier is standing in front of that gate B, will approve that okay, this fellow knows the path and he has came out of B. Okay, this is the scenario. So advantages: enhanced privacy, strong security, versatile application. Of course, challenges are it is more complex structure, performance concerns are there, as it is based on intensive computations. Understanding, grasping of this cryptographic principle is not that easy, right? So these are the advantages. So what is the future? Increased use in blockchain technology and decentralized finance systems, ongoing research to improve efficiency and lower computing overhead, and integration with emerging technologies like AI, enhanced privacy, preserving applications. Okay. So zero knowledge proofs are critical innovations in enhancing privacy and security. Okay. Once it gets implemented, then it will be the best sound system that we will have in the security. Understanding and implementing these proofs can lead to more secure system in our increasingly digital world era. Okay, so this is the future of our cyber security. I hope that I was able to take you through all the modern cryptographic techniques which are involving or evolving in the technology field, and their applications are going on, right? So this is how we also should be aware of all these technologies as we are going towards the era of quantum computers and quantum cryptography. So I think I will stop here today, and I really appreciate all of you listening
Hmm.
me so long carefully. And I hope this was interesting for all of you. Thank you. Over to you, ma'am.
Yeah. Thank you, ma'am. On behalf of Department of Electronics and Telecommunication Engineering, Keystone School of Engineering, I extend our heartfelt gratitude to our resource person, Dr. Leena ma'am, for sharing her valuable knowledge and practical insights. Thank you so much, ma'am.
Thank you.
And thank you, participants, as well. Thanks a lot. Have a
Thank
great
you.
day.